All right, we are live. This is Hangops for December 18th, 2014. It's a special Thursday 10 a.m. Hangops. And we are here to talk about something that's really interesting, something I spent a fair amount of my time at Mozilla working with these folks and working on. It's how Mozilla tames the Firefox crash reports beast through Socorro and some other interesting things. It's a really interesting ops challenge, development challenge, distributed system challenge, and sort of I think this topic has been like a year in the works, so it's really cool to have everybody on. Why don't we start with some introductions, and then we can just sort of like dive into what the problem set is and how we're solving it. I think it'd be cool to also like do some of the historical narrative going back to like even I think Laura, I think it was you and Corey Shields, who's not here, who did some of the you did a talk. I think it was OSCON like 2009, 2010 about some of the like early like database migrations, H-based stuff. Like there's a lot of really cool stuff we can unpack. And I know right now like moving into the cloud is there, so there's a lot of stuff to topic. But let's start with some introductions. We'll start with my left. Lana, you want to say who you are?
Hey, I'm Lonan. I work at Mozilla. I am the current owner of the whole Crash Reporter Socorro, and I've been working on it for almost 4 years now. Um, and yeah, I've worked on it's a distributed system. I've worked on most parts of it, and yeah, now I mostly manage the team that works on it. So not a real engineer anymore, but that's all right.
People engineering. Awesome.
People engineer.
Frosty, aka Dan. Oh, uh-oh. We lost Frosty. He'll come back. We'll jump to you, Laura. We cannot hear you. There you go.
Now I'm unmuted. I sort of feel like kind of an imposter today. I used to run the crash reporting system, but I punted it to London, which is really nice. It's kind of fun working on it right now, or looking at it right now, because these guys are busy migrating it into the cloud. And I guess 4 years ago we migrated it from one data center to another, and I have like really bad deja vu. Yeah, right now I am whatever you call like the person that engineers the people engineers. So that's middle management. So hi.
Cool. Rob?
Hey, so I'm Rob Elmer. I work at Mozilla, and I actually work on Socorro doing engineering. So I don't engineer any people. I just engineer the bits.
Cool. All right. Well, and we'll wait for Frosty to get back. Why don't? Oh, there he is. Hello. Hi.
Hi there.
All right. Good timing. Why don't you tell our fine viewers who you are?
Yeah, I'm Frosty. I also work at Mozilla. I also work on the cross-chats thing. Of the people currently in the Hangout session that currently work on cross-chats, I have the least experience with it. I've only been on the team for a little while now, but really excited about our migration to AWS. Coming from a sysadmin background, that's my bread and butter. So it's going to be exciting.
Cool. I'm kind of going to open it up to all of you to sort of jump in as I prompt for stuff. But I'd love to kind of start with like the problem statement. I kind of summarized it in the tweets as like taming the Firefox crash reports beast. We'll kind of like talk about the size of that, the volume a little bit, and then we can kind of dive into how that has evolved over the years, maybe.
Sure. Guess I'll field this one. The Crash Reporter right now has about 150 terabytes, a little north of that, worth of crash reports. Crash reports are like a 16 kilobit JSON file median, I think, but they vary pretty widely. They can be a couple megabytes. And we get a couple million of these a day. We process them, analyze them, and try to provide useful insight for the desktop engineering teams so that they can decide how to allocate their time, fixing top crashes, how many people are affected, what regions they're affected, and try and give them some insight into sort of real-world problems that Firefox users are having.
Right, so I'm using Firefox, right, and maybe Java gets sad or whatever, right? All of a sudden my Firefox disappears, and a little thing says, "Hey, you want to submit a crash report?" Right, that's where this whole thing starts, right?
Yeah, there's a set of client libraries that Google makes, or I guess Google started but is made now by a bunch of people, including some engineers at Mozilla, called BreakPad. And they open sourced the client libraries, but they didn't open source the servers. So I guess 8 years ago now, 9 years ago now, Mozilla took it upon itself to write the open source server side of it, free of Bigtable. So it used to run on just whatever hardware we could kind of scrap together from other projects that other projects were given up. And this was before my involvement. But it scaled really quickly and ended up being really useful. And eventually we got resources to do kind of a proper data collection and analysis job. So it's, I don't know, Rob, do you want to talk about the pipeline, what actually happens when a crash comes in?
Sure. So BreakPad does multi-part form post to our server. The way it works right now is it's going to be a little different as we move into AWS. But the way it works right now is we get a multi-part form post. It has a bunch of fields like the product name, the version, kind of metadata about the crash, and then includes a mini dump, which is like a shrunken core dump. It's actually it came out of Microsoft, the mini dump standard. I don't know if it's actual real standard or just de facto standard, but there's a bunch of tooling to support processing mini dumps. So the way it works currently is we collect to the file system, and today we actually just recently we switched to using S3. So we collect the file system, and then we have another daemon that's running on the collector boxes that crashes into S3, and also puts them on the RabbitMQ queue. Then we have processors that they're RabbitMQ workers. They pick up all the info about the crash you want to know. And then we have the Socorro UI that knows how to pull up crashes. So you can pull up it. So if you submit a crash within 5 minutes certainly, but generally within seconds, you can pull it up via the UI. One thing I didn't mention is when you submit a crash, the collector gives you back a UUID immediately, and that's the key that gets passed around the system. That's how it gets stored. That's what gets queued in RabbitMQ, and that's what you can use in the UI. You can go to crashstats.mozilla.com, stick it in the search box in the corner, and you'll get your crash. So we also produce graphs and reports on like what the top crash per day per version of Firefox was, for example. So that's a basic overview. So we can dive into bits of it if you want to. And like I said, it's going to be a little different once we move to AWS. Like the reason we collect a file system was because we were storing to Hadoop before, and to deal with intermittent reliability issues, we would collect a file system, and then if in the event that Hadoop went down, that was fine. We just spool out the file system and then we stick the crashes back in. As we're moving to AWS and like ephemeral EC2 instances, we're not going to want to do that anymore. We're going to want to stick it directly into S3. So, but besides that, it's going to be the same basic system. Maybe we'll use SQS instead of RabbitMQ. We're not really sure yet. So, but I don't want to get too ahead of ourselves. Basic overview right now.
Yeah. Okay.
I think one of the important takeaways from what Rob was saying there is that there's a lot of moving parts. It's easy to think of it as one sort of monolithic piece of software that does all the things, but that's definitely not the case. It's actually a number of independent software projects that are sort of grouped together that all work together. At least that's the idea. And as we move into AWS, that's going to become more and more important to start really thinking about it that way.
Definitely.
For historic reasons, it's like 5 apps, I think, in one repository, at least 5. I think that when we really as you move that kind of sliding scale of breaking up a monolith into microservices, it could make sense to be anywhere from 5 to maybe 8, maybe 10. We'll figure that out as we go along and see what feels comfortable and practical.
Right. So, right, once upon a time, right, we had Firefox, had a few users, started getting more users, right? We start collecting these crash reports. Initially, right, I think the web stuff started, right, and was it initially just file system storage, Laura? Or like, how did things kind of like, what was like the initial sort of architecture to do sort of some snapshots in time of how things evolved as the volume grew and some of those like engineering decisions and stuff along the way? I think that's a really interesting thing to unpack.
Okay, so you should have Lars here for this because he's been a lot longer than me. At the very beginning, they actually tried storing crashes in Postgres, and that was very short-lived. This is like a long time ago, like Postgres 7, I think 6, maybe even. And then for a long time after that, we're on NFS. And what Lana was talking about before with kind of the very heterogeneous architecture, which was basically like a bunch of boxes scraped together from various corners of the data center and junk room. We're all hooked up to a NetApp, so that was all NFS. They had a really fairly large number of limitations, as you can imagine, as well as being fairly expensive. And at the time, we were kind of looking around for something a little bit better. And we had a guy working with us, Daniel, who was super enthusiastic about HBase. So he said, this is the right tool for the job. So we ended up migrating onto that. It's had its upsides, it's had its downsides. It took us a really long time to make it vaguely stable, but it's been stable for a couple of years now. But I think the the conclusion that we kind of came to is that honestly, a use case doesn't require Hadoop, and if you don't have to have Hadoop, then you shouldn't.
Okay, so originally, right, like you have one web service that receives the crashes.
Mm-hmm.
That would take those posts, and initially that was writing them to NFS, and NFS was what glued that to the stuff that did the processing.
Yeah, so you have a processor pick up the crash and and write a bunch of metadata into Postgres. And honestly, that part, it's slightly more complicated now, but that's the core of the system. It hasn't changed that much. Like the abstraction of that is still the same.
That abstraction's gotten a lot cleaner recently.
Yeah,
we just shipped. I don't know. We've been influenced by other companies that are doing very similar telemetry collection pipelines. You have, collector, log processor, with some number of transformation steps, and then ultimately we ended up writing it to a couple different data stores. At the moment, S3 used to be HBase, Elasticsearch, and we write some subset of it to Postgres, and we write a tiny subset of it into a special S3 bucket where we're running classifiers against Firefox crashes to see if we can figure out kind of actionable things for the user to do to make it so that they never hit that crash again. But that's a little experiment that we're working on. But the thing is, that pipeline is so flexible now that we can really do some amazing kind of ops work to recover from system failures with it. I don't know, it's a very cool system that we have built there.
Definitely, and right. So I guess like maybe one way to break this down is that there's sort of like three main say features, if you will, of Socorro. There's the collection of crash reports, which is sort of a matter of it's receiving the crash reports and then persisting them to storage. And then there's the processing, which is taking the crash reports and sort of enriching the initial data based on other data that you have locally within the Socorro system. And then that enriched data is used to sort of provide visualization and reporting through a web interface and an API. Is that a good sort of summary?
Right. Do you want to talk about the specifics? in that, we can talk about that a little bit.
Yeah, what I kind of want to do is kind of like
Cool.
maybe by breaking it into those three, sort of cover
Mhm.
how each of those evolved.
Okay.
Right. So like on the collection side, right? Like that was initially just like stuff would be posted to it, and then I think initially it was written right to Hadoop, but then it was like because of intermittent failures, it was decided just sort of the local collectors, right?
Yeah, I was around for that bit, so I do remember that. Yeah, one of the biggest problems is, when you mention when Firefox crashes and you get the little dialogue that says, "Oh, you crashed. Please submit your crash so we can fix it." When you get that dialogue, and you say submit, it sits there and does the post. So the way it used to work is we would attempt to write to Hadoop for some number of seconds, and if it timed out, we would fall back to file system. The problem was, that dialogue will stay there until the post is done. So if we're hanging for half a minute or a minute, then the dialogue's sitting there, which isn't a huge deal. But people on slower connections, that can be a problem. Sometimes their sessions would time out, or it would just be, we want to collect and hang up on the connection as soon as possible. So we switch, instead of falling back to file system, we switch that around. So we always collect the file system, and then we have a daemon process. We had a daemon process running anyway to do cleanup for things that fell back. So we just switched it around so things are collected directly to the file system. And it was a little before, I think the NFS stuff you were mentioning is a little before my time, but from what I understand of the history of the system, that's directly before the Hadoop stuff came in. So yeah, that's accurate.
Yeah, that's true. And I think one of the great things about the system now is that sort of this idea of storage is somewhat abstracted away. So you can say write it to whatever the primary crash storage is, and you don't actually really care what that is a lot of the time. Like you could switch out S3, you can switch out NFS, whatever it is you want to do. So if you were going to use this as a third party, that makes it a lot easier. It was non-trivial for a long time.
Right. Yeah, that would help. Yeah.
Oh, I was going to say we run a pretty sizable instance at Mozilla, but we know of a number of external deploys that range in size pretty widely, and not everybody. If your crash volume is only a couple hundred a day, you may not need to adopt or want to adopt Hadoop in HBase, which was a real common request that we had. So this abstracted crash storage lets people run it on the file system. We've seen it running on something as tiny as a Raspberry Pi, which is really funny to us because we have more than 100 machines running our massive install, but it scales down really well, which is important for the outside folks that we have running it.
Right. Yeah, I was going to say we recently moved from HBase to S3, and that was just a configuration switch. So we to do the transition, we just in the configuration we just we enabled S3 as a crash destination for the collector, and then as a crash source for the processor, and then we were putting crashes in both places. And then in the background we synced HBase over to S3, and then we turn off HBase in the config is our last step. So it's really flexible, and it's really easy to write new crash storage sources, and they're basically just sources and sinks for the collector and for the processor and the collector. And they're pretty straightforward to write. We've abstracted away a lot of that stuff. A couple of people on the team that aren't here today worked on this config man, which is like a configuration management system. It also does some. It basically abstracts away a lot of the problems we have with command line tools, with configuration. It makes it really straightforward to write new crash sources for Socorro. So if you look at like RS3 specific code, it's very tiny. It's really just a shim over Boto.
There's a nice side effect of some of that abstraction too. That once you become comfortable with it, it's easy to become efficient when you're writing, new crash storage types or whatever. What's interesting about that too, I think, is that if you're writing subsets of existing crash storage types, you don't have to go and write a whole bunch of code. You can just go, I want this and I want that feature, and you're gone. It's like an afternoon of work. So that's quite exciting too. The learning curve kind of goes like that and then like that, right? It takes a lot of effort to get sort of that perfect crystal structure into your head, and I don't have it yet. But once it's there, the level of productivity in terms of deploying new features and doing new and interesting things is very high.
Yeah, one of the things I think was interesting about the collection piece is that initial post, right? You talked about how because you're a browser vendor and you're used globally, and the distribution of good connectivity is very asymmetric. There was a UX problem because you wanted to confirm that that was posted, and so if the post process, the sort of the pipeline of just receiving and persisting the post involved a data store, right? That was sort of like non-trivial to always guarantee a right to, that UX could go down. And so, what I think for a lot of people might seem like almost like a step backwards. Like, why are you putting it on the file system, right? That was an engineering decision that really like improved the UX because it's simple. Like, you put it on the file system, it's there. It's not going to be there very long, ideally, but it's like just sort of a very quick decision there. I think that was kind of an interesting one. And it's like when I first sort of came up to speed on Socorro and saw that, I was like, that makes so much sense. Was my initial reaction.
So that fell out of two things. One, early adopter of HBase, and Hadoop. We picked it up way earlier than we ever should have. And two, scrounged together hardware. So we've been dealing with ephemeral connection failures since before the cloud was a thing, which really affected, we have thought very hard about the consistency model of our system, and not in the sense that is kind of popular these days, where people talk about, is my sharded database, where does it fall in cat? We have been thinking about that without using those terms about the whole system of 5 apps, because we've had to deal with these ephemeral network weirdnesses for many years.
Definitely. And I think too it's interesting, right? Like, when you start thinking about the consistency, availability, partition tolerance, too, looking at your sum, what is the sum of the system, its consistency, and then you sort of you have to look at for overall, and how different pieces don't need to have the same, sort of CA or AP properties. So moving on from the collecting, I think a lot of where the magic happens is in the processing. Right. So you with this sort of shrunken crash dump. How do you make that useful? Right. This process. What do you use to enrich that?
Right. So when we build Firefox, we generate debug symbols. We don't, but those are, normally if you do a build yourself, normally you build and then you strip the binary of the debug symbols because it makes the binary smaller. And that's how we ship out to users. But what you can do is you can keep those debug symbols around. So when the stack dump comes in, so we get this mini dump, and that's what the processor is processing. It's running a tool called Stackwalker. And what that does is it takes the symbol file, it identifies what version of Firefox this is, identifies where the symbol file is, which currently gets it from NFS, it's going to be S3 soon. And it reassociates the stack trace with the symbol file. So when you get the stack trace, you just have the memory addresses. That's not very useful. But when you reassociate it with the symbol file, then you get the function names, so you get an actual real stack trace. So that's the useful thing processing. You can tell what line of code crashed. And then from the Socorro UI, you can link out to Mercurial, to our version control system, and get and look at that code that crashed. So that's, it helps people to be able to quickly jump from, a crash happened on this line, here's the source code, and get closer to a fix. You can also do things like file bugs from the UI, other things like that. But it's all really predicated on getting a stack trace with that's been put together with the mini dump that's been put together with the debug symbols.
And now you also have some tooling built to receive symbols from third parties, right? Like for like Flash and other things, right?
Yep. Yeah. So we have an API. Socorro has an API that is it's kind of a nice interface. It's like a self-documenting API and CrashStats/API. And one of the things that we allow authenticated users to do is to upload symbols. So our for Firefox OS, our platform partners can upload symbols. Adobe can upload Flash symbols. So then we get meaningful stack traces from things that crash even when we don't have the source code, because we have the symbols, so we can reassociate them. So that helps us, and also helps partners like folks over at Adobe to debug crash problems in Flash.
We also have
Definitely.
built into the reporting, we have a pretty fine-grained permissions model, not just for uploads, but for accessing different subsets of the crash data that we get out of it. Because with a crash comes the contents of memory, which could have anything in it. So we can offer access to the public, or access to interested contributors for debugging, or access to third parties that are interested in how their plugins are failing in Firefox, without risking exposing sensitive information about our users to them, which I think is one of the other really nice aspects of the Crash Reporter that you don't necessarily see elsewhere. It lets us operate in the open as possible, without compromising some of the safety and the promise to protect sensitive info that our users that we make to our users when they decide to upload a crash to us.
Yeah, and I think that's a really cool piece, and also an interesting challenge in terms of the PII, publicly identifying information, because you have anything from like the IP it came from to like whatever is in the browser. It'd be on Amazon. They could
Partial
have been
emails, credit card numbers, if they were midway through filling out a form, all sorts of sensitive social information that they may have been posting in a private email, etc.
Yeah. So one of the things I always thought was sort of interesting with the processing piece is that's sort of where you traditionally think about applying like a queue and like workers, and that I don't know where it started, but I know when I initially came in, it was still like using like a database as a queue to farm out the work initially, right? And we did a migration to a message queue. Could you talk about that a little bit and sort of how that evolved? I think that's not an uncommon sort of set of patterns that happens as a web app grows up.
Right. Well, we used to have a table in HBase that was basically our queue for incoming crashes, and then processor and delete records, delete rows from the table basically, and as it read them, and then it had its own Postgres table for managing the pool of processor workers. As you can probably imagine, I mean, both HBase and Postgres tables aren't meant for doing that kind of thing. It hurts performance of those systems, which was one of the big reasons to drop it. It's also just complex. You need to handle things like, what if a worker takes a job and then disappears? So you have to write your own code to handle that kind of stuff. That's the kind of thing the RabbitMQ, if you use RabbitMQ and use a library for it, that's all done for you. A lot of other people use that code. We were able to get rid of a lot of custom code and get rid of a lot of weird edge cases we didn't need to worry about anymore. And improve the performance of both HBase and Postgres. So that was, it was a pretty good deal overall, I think.
And going forward, as we move to, well, go ahead, Frosty.
As I say, it's nothing's perfect though, right? Was it an improvement? It's absolutely an improvement. But moving to say RabbitMQ comes with its own pitfalls too, right? Sometimes it can be difficult to have visibility on exactly what's going on, within the queue architecture and whatnot. And we've run into issues where things were getting backed up, for example, for one reason or another, and it was difficult to ascertain why that was happening. So we'd see the queues would start to fill up, and we'd know the queues were filling up. We had no idea why they were filling up, where particular messages were coming from, what consumers were failing to consume them. So while there was a clear improvement in terms of overall performance and reliability, it introduced new problems, new operational problems, in terms of understanding how to admin RabbitMQ. And moving forward into AWS, we're going to be encountering this again, right, as we go to a new platform, as we new operational concerns. So, just sort of a fairly be thee warned story, right? Moving from database to a proper queuing system solves some problems and creates others.
Right. It adds a whole new space where you need to add new kinds of telemetry, right? And like as you go from like, right, maybe you've got like, a CRUD web app, a couple web services running together on some web servers and a database, and maybe some file storage, right? As you add new things, each thing means you need new logging, you need new telemetry, you need to expose new instrumentation, not just on the new, say, data store, right, like on the Hadoop side, but also you're to potentially emit new kinds of metrics. And then as your metric volume goes up, there's a whole new operational challenge of your metric store, whatever pipe. So it's this like, the bottleneck constant. Right. So Socorro evolved, right? Originally it started, I think everything was PHP on the website, right? And so you'd like PHP and Postgres and a file system, and then PHP, Postgres, file system, and Hadoop, right?
Actually, not quite true. The very first version of the web app was in Python. They rewrote it in PHP. Everything comes full circle.
Okay.
It was like pylons or something.
Okay. So you had PHP for a long time, and that came with some Memcache. We had RabbitMQ into the mix. Then the web app gets rewritten in Django. So now you've got like Django web servers, you've got Memcache there, you've got Postgres database, right? You've still got some NFS for the file storage, you've got Hadoop for crash storage.
Don't
You've
forget
got
about
a couple
Elastic.
tiers of these sort of that was added on at one point. I was kind of getting to that, but even before that, you had like two sort of tiers of these Python services, right? You had the crash receiving and the collectors that process from the file system into Hadoop, and then you had the processors, right? And those were using Postgres, and then RabbitMQ got added into those for the processing pipeline. And then as you wanted to enhance the data enrichment, right, and maybe move some stuff that wasn't best suited for Postgres, now you add Elasticsearch. And what drove that?
Well, so we also have most of our data stores were wrapped in an internal Python API, which is an artifact of the PHP web app, because we had some engineers that wanted to work on PHP without Python, and some engineers that would work on Python but refused to touch PHP. So we developed this two-tier, one internal API that was Python exposing the data stores, and one public web app that was all PHP. And I think we're about to merge those two together. We've had a pull request that's been in review for a while. It's constantly being worked on, but one of our goals is in the next month to kind of make those into one thing. We no longer need the abstraction layer. But the data store, adding Elasticsearch came along because we had built this interesting search functionality when we were at low volume of crashes, and as we scaled, it did not scale with us, and we had to remove it in order to keep the site scaling on the hardware we had. And developers were furious. They really, really wanted to be able to search like the whole stack trace all the time and do ad hoc querying and a bunch of stuff that was possible but very slow. We were trying to do it in Postgres, and we were having 5-minute page loads at times. Like, I don't even want to say at times. That's not like an upper 90%. That's median of 5-minute page loads on these ad hoc queries. So we decided to do some tests with Elasticsearch, and it's worked out really, really well so far. Probably it is handily the most used thing in our current crash reporter because of the freedom that it allows the engineers as they're investigating problems to sort of change and refine their ideas.
I actually have a comment on that, which is when we moved to HBase, there were all these bugs marked as they just had like a whiteboard tag of cloud because people sort of thought that all of these, they were all search-related bugs. They thought they would be magically solved when we moved to Hadoop, and as you probably know, it's not going to solve that problem. But Elasticsearch has solved most of those. It's just cloud solves everything.
Definitely. And of course, Elasticsearch has brought its own, operational knowledge, growth, and new points of like telemetry and things like that, and scaling. Just keep hammering on that point. But maybe a little bit of a side road for a minute. Mozilla in general, like I know, sort of started with as sort of a, let's say, a PHP shop in general on the website, and then evolved to more of a Django side. Generally we're running stuff under Apache. So as Socorro grew and you started adding these components, right? Hadoop, Elasticsearch, RabbitMQ, you're now running things that are on Erlang or on the JVM. Like, what was that like? Sort of, adding other runtimes that maybe you're not as familiar with an operating and introspecting, etc.
There's nothing good about the JVM. That's all I can say. I think if you're from like a Java-ish background, then it's fine. But adding the JVM as someone who is not like comfortable with the JVM, I think is one of the most painful things we've ever done. So that's from a Hadoop perspective. On the later things like Rabbit, I don't think we've had as big an issue that I have seen anyway. But I haven't been as involved.
So it's a curious artifact of how we operate embedded within Mozilla. We have, as a team, a lot of former operations people on it. Frosty, sysadmin background. Rob was a release engineering background before this. I was a sysadmin for a few years before I switched over to being a developer. And we, as a result, have a lot of leeway, authority, and more control over our infrastructure than most other teams in the same space at Mozilla. But we still work with the existing IT and operations team. So parts of our infrastructure, like RabbitMQ, are entirely administered by them. So we have a lot of insight, as much access as we want to most of it, but then there's this little like one-off service that they run for us, and that purely organizational political barrier can make it very difficult for us to have a peek into what's going on there. So some of the problems that Frosty's described, where all of a sudden the queue's backing up, we will see Nagios starts singing to us pretty aggressively, and we do not know why and have very few tools to go after it. So we get this kind of indirect debugging where we can go look at our system and how they're interacting and how the failures are manifesting for us, and try and infer what's happened. A couple times we've been able to find, like, oh, switch went weird on us, and now Rabbit is definitely split-brained, which has been...
Yo, bro.
Yeah, that's some little detective work on our end.
Detective work. Sounds nice.
So that is, in as far as we can look at, in as far as we can do...
Yeah.
In as far as we've had trouble running other virtual machines or introducing other ecosystems to it, I think the organizational barriers have far outweighed that.
It's Indiana Jones.
Goodbye. So, just an observation, and I don't think this is uncommon to, especially as you're more on the engineering side. Some services you are going to depend on within an organization are it's almost like an internal SaaS, right? An internal PaaS sort of a thing. And so the potential challenges around introspection, especially being able to dive deep, are similar to if you're going to consume some of the sort of second and third level, abstracted like AWS services, things like S3 or SQS or Kinesis. So what have you done, like, in terms of, maybe we'll call it defensive engineering, uh, as you depend on things that are essentially black box to some degree or another?
One of the we touched on this a little bit earlier. This idea that we've been dealing with, network flakiness and other sorts of stuff for a long time. The idea of building, resiliency, the idea of building caching, the idea of building buffering, the idea of building retrying, and so on and so forth, sort of comes at every layer. And when you talk about interacting with things that are sort of black box, that plays into it as well, right? The philosophy just sort of continues. Except that there are elements of the system that you're not going to be able to control fully and deal with that, right? Accept that failure is going to occur, and then try to fail in graceful ways.
So words like loose coupling.
Words like, yeah, loose coupling. Words like, APIs. Words like transaction executor with limited back off. Things like that.
It affects the way we look at uptime too. Like, for collection, we're very concerned the collector's always up, that we don't lose any incoming crashes. We have a different way of looking at the rest of the system, because if processing is delayed, it's okay. We haven't lost any crashes. We want the UI to be up and people to be able to get their reports, to be able to get at individual crashes. But those things come after collection. So I think having those systems decoupled makes a lot of sense. Just from a we can always, so the thing is, the incoming crashes, we call them raw crashes. We can always reproduce the process crashes. We could lose all process crashes and recover from that potentially. Same, we could lose all our data. We could lose Postgres, we could lose Elasticsearch, we could lose the UI, and we could recover from that as long as we're able to keep collecting the raw crashes and catch up on our backlog. So I think operationally, it makes a lot of sense to keep those things decoupled as much as possible.
One of the cool bits about that new processor we were talking about earlier is the ability to basically replay the crashes, almost. We've had a couple times where we've had to make a change to the processing pipeline, and then we go back and reprocess, or effectively just replay the incoming crash stream for the last day or the last week in order to pave over the data. So we do think about it in terms of risk. There are things that failures we can't recover from. We can never get those crashes back if the transmission's interrupted. And there are things that are really low risk, and we're happy to play a little fast and loose with, like the web app, because we can tweak that pretty quickly. And if it's down or if a feature is broken for an hour a day, that's probably okay, because we're not going to lose any data. And the transformation steps in between are all some sliding scale on that, but in general, we can recover or replay almost anything at this point.
Very, very cool. And that piece about replaying stuff, I think, like, the word would get tossed into that kind of conversation, right? The idea of, like, I can safely rerun the same thing over and over again, and if I can't safely execute my quote unquote idempotent action, I fail rather than commit, right? Is that kind of?
Yep. Yeah, that's the same also both for we have kind of an aggregate reporting system. That's the thing that gives you graphs and top crash by signature, or top crash ranked by other things, although by signature is the most important thing that we've found so far. Those can be redone, and it's exactly as you described. Like, that's in Postgres, so in a Postgres transaction, if anything fails, we roll it back. And you can always, the way we've written all the Postgres stored procedures, you can always rerun, like yesterday, for example. You can rerun all the reports for yesterday if there was something wrong. Like this is probably a good example because there was something wrong yesterday. So we're transitioning off of HBase, and it went down for a good part of the day, which delayed crashes. It delayed moving crashes into HBase and S3, so it delayed processing. So we caught up with that later, but it was after all the aggregate reports had already run. So we were able to just run a simple backfill command in Postgres, and it automatically redid all the reports for yesterday. So we can do that on the Postgres side. We can also do it like Milan was describing on the actual processing side. Like if we add a new processor rule, or we change the way we treat incoming crashes. Like say we upgrade our processing tool that analyzes the Stackwalker tool. So we do an upgrade on it that fixes a bug. Maybe it was non-analyzing, not putting the stack together correctly. We can very easily and quickly and reproducibly rerun, reprocess all those crashes. So it was really worth it because now it's really low maintenance.
Very cool.
Yeah.
Yeah, definitely. There's a couple ways I want to go here. We'll go with that. So one of the interesting things, even when I was still Mozilla in WebOps, and I spent a number of quarters in, I guess it was 2013. Yeah, it was 2013. Kind of, partially embedded with you guys. Sorry, you folks. We were already even talking about could we do AWS, because there's some interesting things there, especially with the sort of decoupled nature that Socorro has evolved into. So things like auto scaling, and the potential as new instance types come out, and you optimize performance, SSDs, things like that. I'm just curious where those things are on your modality, and how much are you looking at? Like, can you wire in auto scaling to stuff, or what things does moving in AWS open up for you? What are the upsides besides like S3?
Well, I would say honestly, S3 is actually a big one. So let's not gloss over that, frankly. But beyond that, it's just something that we're giving a lot of thought to in recent weeks, especially. And this whole idea of having loosely coupled components, and this whole idea of dealing with ephemerality, translates very well into AWS space, and we've sort of flipped the perspective on it a bit, and instead of treating it like a problem and going, here are negative things that we need to deal with, we flipped it around and went, how can we turn these into positives? How can we look at a system that we don't control the hardware, and nodes come up and down, and things can happen, and actually turn that into a positive? Auto scaling. It's my belief that auto scaling is a pipe dream. I hope to be proved wrong on this, but we're going to find out. But the whole idea of doing deploys, for example, of machines into production to do very specific things, microservices and whatnot, instead of going, here's a monolithic item and we're going to deploy it and it's really delicate and hopefully that machine never goes down because if it crashes we're screwed. Instead we go, here's a machine and it's in production and it does this one thing, and if it disappears, nobody cares. That's a way to turn that ephemerality into an advantage. And that's one of the things that AWS is going to be giving us. If anybody wants to expand on that, or I could keep talking.
Sure. I linked a bug in channel 2 that's we're tracking what we think we're going to be able to optimize really easily in AWS. So things like using SQS instead of RabbitMQ, that would just help us operationally. We'd have less to manage ourselves. Things like spot instances processing is one thing we're considering. Elastic load balancing for collection most likely is where that would make the most sense, at least initially. There's some other things that just by virtue that we're moving into a different environment, it gives us a chance to do things like upgrade and change some of the basic system dependencies. Like we're looking at one thing, some of the tests I did before using Nginx Apache with ModWSGI. The main thing with collectors is collectors are mostly constrained by memory on how many sessions you can handle at the same time. So that's one thing that would easily let us handle more sessions per instance, given the same instance running Apache and MongoDB. So, and then I think that's, yeah, some other stuff that's more specific to us, like enabling compression in S3 storage, for example, would save a ton of disk space and therefore cost for us. So a lot of this stuff we need to, we need to measure it and we need to actually test it before we deploy it. But it all sounds like no-brainer kind of easy wins that we're looking forward to.
One of the things that we're trying to avoid, where possible, is locking ourselves tightly into the AWS ecosystem. It's a garden path, right? As all walled gardens are, I suppose. It looks really attractive on the outside. The marketing glitz is very, very nice, and everything works nicely together. But along with this philosophy of decoupling, along this philosophy of a lot of different moving parts that work together, comes the philosophy not want to lock into the AWS ecosystem. So, that's a part of it too. And another part of it is just simple, reality and operational concerns. It would be nice to not have an AWS dependent system from start to finish, right? It is advantageous, tactically speaking, to be able to migrate your critical software infrastructure, business critical elements, onto other platforms if needs be. I'm not saying it's a walk in the park. It's not like tomorrow we're going to go and deploy this to Heroku just because we can. But the ability to migrate is a valuable one.
Right. Yeah, I agree. I mean, there's definitely a tension there between, I think one huge reason to keep it flexible is we need to be able to run it locally so we can develop it, right? So that's something that you're not necessarily going to want to use SQS and S3 for your local dev instance. You may be offline, it may be too slow. I think those are good reasons that we're going to have things like file system support and RabbitMQ support. The nice thing, kind of going back to what we said earlier, the nice thing about it is to enable RabbitMQ and Socorro is just a config switch. It's just another thing that the collector, you tell the collector, okay, put the ID onto this crash sync. And then in processor, you say, okay, pull the ID from this crash source. So RabbitMQ is implemented as another crash source, just like Postgres, just like Elasticsearch, as crash storage rather, in Socorro speak. So one thing is it's really nice is we're very flexible on that side. The other thing that's kind of an interesting tension, at the same time though we don't want to maintain, we have to be cognizant of how much code we maintain. Like if we maintain support for HBase and we never test it or use it, and nobody uses it or tests it, it's probably going to bit rot. Or we have to maintain an expensive test infrastructure just for that, right? So we need to be cognizant of that. And also we have the other thing that's a lot of external Socorro users, a lot of game companies especially, but a lot of just random software companies out there have like Unity 3D, I know, for example, just got their instance up and running. And a lot of people are out there running Socorro instances themselves too, and they're on all kinds of wacky infrastructures. Sometimes they're in a hybrid, cloud, something else. Sometimes they're on pure AWS. Sometimes they're just on a VM in their infra. Sometimes they're on physical hardware. It's really hard to tell. So, we get a lot of requests from them, and there's definitely, definitely we help them out where we can. But there's always, tension there because, even if somebody contributes the code, we need it to be tested and maintained over time, and that means our test infrastructure needs to support all that stuff, right? So that's one of the things that gets really complicated as we go into this. Is our test matrix kind of explodes. But I think what Rusty's saying makes a ton of sense. That's we definitely want to maintain the ability to run Socorro outside of AWS. I think for local development, if for no other reason, but I think it's also a good to not, be completely locked into AWS ecosystem, because there's other cloud providers out there that do programmatic infrastructure. There's Azure, there's Google's got it. There's some smaller players, there's Heroku. So, there's obviously, obviously we don't want to couple ourselves super tightly with AWS, but I think what it gives us in terms of programmatic infrastructure, the fact that other people are using it in Mozilla, makes it a big advantage for us. But we have to hedge our bets a bit.
So we physically got together a couple weeks ago, and we were trying to resolve some of the design decisions about how to move to the cloud. and that was an interesting conversation. It's still ongoing in many ways, but talking about, can we use this tool or that tool? Do we want to rely on an Amazon built-in? We've been looking real hard at some of the stuff coming out of HashiCorp for helping us in the migration. We will be effectively taking over most or all of the operations work instead of relying on any shared infra. So we're looking at heavy automation coming up and thinking about what the right level of abstraction is for development. Like Rob was saying, we don't want to lose, we don't want to sacrifice local development as we move into these hosted environments. So, right now we're leaning pretty hard towards Heroku's 12-factor design pattern for a lot of our code apps. That way, when if CoreOS eventually comes up and we start feeling real comfortable about it, or if Atlas turns out to be really, really great, or if there's a big, push to whatever the next platform is, 12-factor strikes us as like the right level of abstraction and compromise for developers. But all of these things are kind of ongoing, and I'm really looking forward to settling the problems and writing some blog posts about it and building some sort of institutional knowledge center of excellence, I believe is what my senior director whatever would say. So looking forward to sort of building this up and learning as we go, finding the traps with our hit points, I guess.
Is Brandon on mute? You want to? Is he okay?
Sorry, I lost my Hangout window. Too many Chrome windows. I do use Firefox, but I use Chrome for Hangouts because. Real quick, and we're coming up on an hour. But this is a minor question, and I know probably Selena, right, who is the Postgres whiz on the team, is probably the best person to answer this. But it's just I'm curious, like, as Postgres evolved and as the JSON stuff got added to it, and be inside the core system as JSON, I was just curious, like, if that opened up any interesting stuff that you could do inside Postgres that you might have otherwise been looking at another data store or another tool to do.
There's a small turf war, I guess, between the two data stores that we use that store things in native JSON, which is Postgres and Elasticsearch. My third-party outsider observer on this is that if we hadn't had implemented Elasticsearch, so if that had never happened, we hadn't discovered it or it didn't exist or whatever, that we would definitely be doing more interesting things with regards to the native JSON store in Postgres. But we did discover Elasticsearch, and we did implement it, and it is being used, and our customers, if you want to call them that, are happy with the results. So, I don't know if for us today there's any real need to go down the path of native JSON store in Postgres, which isn't to say that it's not useful. It's just that Elasticsearch is meeting our needs in that department right now.
Right. I think one advantage, it's relatively minor, but one thing that, so incoming crashes, metadata, as well as the process crashes, we store as JSON. So that's great for Elasticsearch because it takes JSON natively, it lets you search over documents. The one thing I think PostgreSQL that would be really useful for us to use the JSON native support, and the only reason we don't right now is performance, which, with 9.4, which just came out, is supposed to be better. JSON B, especially. The one thing that would be a nice advantage for us is we currently have a table in PostgreSQL called reports, and it gets a very small subset of the crash, and that's what we use for generating all our aggregate reports, like crash by signature, graphs, and all that stuff. That's one area where it'd be really nice if it was schemaless, because crash reports can change. Like sometimes they have a column, sometimes they don't. It's really hard to say, Firefox on Android might have all these extra columns, or the Firefox OS might have all these extra columns and not include something desktop has. So it's really nice to be able to stick everything in as JSON, and then when you generate your reports, that's when you clean everything up and you generate aggregates and you stick them in the right output tables, like materialized view tables. That's the one place where I think it could. We will probably end up using it. I think Frosty's totally correct in that I don't think we're going to be doing things like search, indexing JSON and then doing search across or anything like that, because Elasticsearch is so good at it, and it's so easy to scale Elasticsearch, compared to Postgres. That said, Postgres is a durable data store. Elasticsearch isn't exactly, is exactly durable, so it has some advantages there. It's good for kind of application metadata. So I think we'll probably end up using it more, but I think it's I think Frosty's totally right. Is that we probably could bend PostgreSQL to do what we're using Elasticsearch for, but we'd have to do a lot of the work. But I think there's some advantages to it, because I think when especially in that kind of situation where you want to be really flexible in the data you're importing, but then you want to go over it with a fine-tooth comb and remove everything that looks invalid and generate aggregate reports into output tables. I think it might be really, really ideal for that. So, but it's a very narrow use case.
Yeah, that makes a lot of sense, and I think it's interesting as to sort of reevaluate what you're doing with them. But also, if it's not broke, don't fix it. Resist new shiny. We're at our time, and one of the things that's really cool about this is that it is open source, and there is a community around it. So if someone who's listening, now or later is interested, they're like, ooh, I need that, or I just want to learn more about it, where to sniff around more, maybe get involved.
There we go. So, the source code is all on GitHub. I'll drop a link into channel, github.com/Mozilla/Deborah. There we go. From there, we've got links to documentation and source code releases, a public mailing list that is pretty active. And if you are interested in getting involved in the development, we meet. We have a weekly sort of, I don't want to call it a coordination meeting, but I think that's actually what it is. We get together on Wednesday afternoons, or Wednesdays at 11 PST, and talk about the development of it, feature plans, and the state of Mozilla's instance of Socorro, which we call Crash Stats. Also, we are in irc.mozilla.org/#Socorro. It's a cool place to hang out. There are a lot of the admins in charge of the external installs of Socorro at other companies are in there, and there's a lot of good shared knowledge to be drawn on if you're trying to get it up and running for you or your company.
Thank you all very much for this and the evolution and the challenges, and it's really good timing now because there's a whole new hill that you're all climbing with this moving to the cloud, and yeah, so thank you. And with that, we will sign it off. We have another Hangops tomorrow. It's sort of a twofer holiday extravaganza. We're going to be talking about. We're talking with Jessie. I think it's Frizzell. Might be Frizzelli. She's a core Docker contributor, and she uses Linux on her laptop and runs pretty much everything in containers, like Skype, Mutt. It's a really sort of interesting workflow that she's got. So we're going to talk about containerizing your desktop and what that means, and probably just a lot of Linux on the desktop type topics, which seems to be coming back. Unfortunately, the last couple OS 10 releases have been mixed if you're a power user. So it seems like Linux.
Is 2015 going to be the year of Linux on the desktop? Because I've been waiting. I've been waiting for about 20 years.
It might actually be for at least the 1%ers of insanity. I don't know, but we're gonna get into all that sort of stuff. Linux on the laptop, Linux on Mac hardware, containers on your laptop, desktop. Tomorrow at 11 a.m. So that should be fun. So we'll see you all then, and thanks again, everyone, for your time.